All right. Um, you guys should be still working on your quiz, so I figured today should be kind of a light lesson. And here's what I have in store. The next thing we're going to work on is going to require you guys to revisit operations with radicals. So we're just going to do a little mini radical operation lesson. So if you've seen this, you feel comfortable with it, skip it. And if not, let's work through a couple problems. So for this first one, we have negative 3 times the cube root of negative 3 plus 2 times the cube root of 162 plus 3 times the cube root of 81. So when you add or subtract radical expressions, you need to make sure you have the same number underneath the radical sign. Um, Unfortunately, we don't, so we need to do a little bit of work. And here's what I see. I, in my head, see that I'm making chicken pot pie. This is like -1 and a 3. This is like 2 times an 81. And this is 3 times a 27. So I need to make sure that I have the same number underneath the radical sign. And what I notice is with the second one, I have an 82 here and I had an 81 there. I'm sorry, 81 there, 81 there. So I'm going to rewrite this as 3 times 27 and actually use that information to update this. I can make this 6 times 27 underneath. And let's talk about why I would do that. If you notice, for each of the numbers I have, I've listed one perfect cube. -1's a perfect cube, 27's a perfect cube, 27's a perfect cube. Which means that underneath the radical sign, I can go ahead and cube root each of those underlying numbers, right? So I really have -3 cube root of -1 times 3 plus 2 cube root of 6 times 27. Did I do that right? Yeah, I did. Plus 3 times the cube root of 3 times 27. And each of these numbers I'm underlining right now in green are the cube roots that I can take out. So the cube root of -1 is -1. So this -3 is going to multiply by that cube root of -1. So it's going to produce a positive 3. Cube root of 3 plus cube root of 27 is 3. So 2 times the 3 I get from here will give me 6. So it'd be 6 cube root of 6 plus cube root of 27 is 3. So 3 times 3 plus 9 cube root of 3. And so from here, I would go ahead and combine my like terms. The only two like terms I have are the 3 radical 3 and the 9. I'm sorry, the 3 cube root of 3 and the 9 cube root of 3. So altogether, I can say I have 6 times the cube root of 6 plus 12 times the cube root of 3. And that's all I could do to add because the 162 doesn't allow me to do so. So that's pretty much it for this video. One other thing I would like to note is if I gave you a dividing problem, so like the square root of, I don't know, 90 over square root of 2, you could combine this into one giant radical problem, so like square root of 90 divided by 2, or you could just think about it as 3 radical 10 divided by radical 2, in which case you would still combine it, because this should just be 3 times the square root of 10 divided by 2, which should be 3 radical 5. And this one should be the square root of 45, which is 9 times 5. So I still get 3 radical 5 either way. It's just different ways to think about it. When you're multiplying, you can multiply any numbers that are underneath a radical sign as long as the index is the same. So what I mean is, if I give you like the cube root of 5 times the cube root, times the square root of 2, as it's currently written, you cannot combine these because the indices are not the same, meaning this is a cube root and this is a square root. If you wanted to, you could rewrite them to have the same sign underneath, right? This would be like the 6th root of 25. So 3 times 2 gets me 6. 5 to the second gets me 25 times the 6th root of 8, because 2 times 3 gets me 6 and 2 to the third gets me 8. So if you wanted to, you could write this as the the 6th root of 200. But don't worry too much about that one. That's like a special case used every once in a while. Good luck tomorrow.